These are the solutions for the review for the final test, questions number 138 through 143. So taking a look at our first problem here, it talks about two cars leave town at the same time. So whenever you see that, that tells us that we are going to have the same variable if we're not given the time. Going in opposite directions, that gives us another clue about the problem. So what we know is that one car is going this direction, the other is going this direction, and we're going to be given a total distance apart. And it says that the total distance apart is going to be 450 miles. So neither car has driven that full 450 miles, but they combine to make that. And so it gives us the rates at which they drive to. 35 miles an hour, one at 40 miles an hour. So let's go ahead and set it up. Distance equals rate times by time. And we've got two cars. So we'll say that the slow car first is 35 miles an hour times by the time. We don't know the time, but we know it's the same. The other car at 40 miles an hour times by the same time, because they left at the same time. Now we've got to write an expression for the distances. Now again, neither car has driven the 450 miles. So let's go ahead and call one of the cars D. I'll call it the slower car. It drove D miles. The other car, since we have a total, is going to be 450 minus D. And that's the key. So we go ahead and use the substitution method here. So we'll take that 35t and we'll substitute it in for this d down below. So let's go ahead and rewrite what we've got. 450 minus 35t equals 40t. And so when we go ahead and solve, notice that we're adding the two rates. And on opposite direction problems, we always add the two rates. And then we do something else. So let's talk about that once we get to the next step here. So let's rewrite it. 450 equals 75t. So what we always do is add the two rates, but then divide by the total distance, and that's what we're doing next here. So when I divide by 75, it goes in there 6 times. So 6 hours is the time in which they will be that 450 miles apart. So here we've got two cars leave the same town, again, leave town at the same time, so we know something about time. If we don't know it, it's going to end up being t in opposite directions again. So we get another chance to do the same type of problem. So again, we don't know what the distances are, but they're going to give us a total distance. See, if we continue reading, it says, in how many hours will they be 206 miles apart? So we've got a total distance. And so we set it up the same way. Distance equals rate times by time. And so our one car is traveling at 55 miles an hour. The other car travels at 48 miles an hour. We don't know the distances, so let's call the faster car D this time. And the slower car is going to be 206 minus D. So again, it doesn't matter which one you call D. The other is going to just be the total distance minus D. So 206 minus D. And then you just use that substitution method again. So you can see when I substitute that 55t in for that D there, we end up with 206 minus 55t equals 48t. So when you go ahead and solve for t, when you isolate the variable, you've got to do an opposite operation. And you always end up adding the two rates. So we add the two rates together, and that gives us 103t equals 206. And so when you do the division problem, divide by that 103, and we'll end up with our value for t. So t is going to end up equaling 2. So 2 hours is how many hours it's going to take them to be that far apart. Next one talks about Ted's average driving speed for a 12-hour trip was 70 miles an hour. So whenever they give you the average driving speed and they give you the total time, we're going to end up having a rate and a time, and we're going to end up multiplying those, and that's going to give us the total distance apart, or the total distance that Ted ended up driving. So 840 miles. And so then it says during the first 9 hours, so 9 hours is a time, we'll put that there, he drove 60 miles an hour. So we write 60 in for time. So let's say how far he went. Well, we multiply those two numbers. 6 times 9 makes 54, and just add a 0. And so then the next part is the question. What was the average speed, so we don't know what that is, that's R, for the last 3 hours? So 3 hours. And how do we find this distance? Well, I've got a total distance. I've got a part. Let's just subtract those two. And so when I subtract, I get 300 miles is the distance he drove that last 3 hours. If I divide by 3, that's going to give me his average speed for those last 3 hours. So 100 miles an hour is how fast he ended up having to go to average 70 miles an hour. Well, here we have Ann's average driving speed for a 5-hour trip was 80. So same type of problem. So distance equals rate times by time. Average driving speed for a 5-hour trip, 80 miles an hour. So we go ahead and multiply those two. We end up with 8 times 5 is 40, and add a 0, so it's 400. During the first 3 hours, so 3 hours, she drove 90 miles an hour, so she had to drive really fast. And then when we multiply those, we get 27 at the 0 at the end. And then it says what was the average speed the remainder of the trip. Well, the remainder of the trip would have been the last 2 hours. We don't know what that rate is, but we can find the distance that she drove. So if we just subtract these two numbers, we'll get that distance. So make sure that you end up borrowing from the 4, change it to a 3, and so we do that subtraction, we end up with 130. And so we go ahead and do that division. Divide by 2, 2 goes into 13 6 times with 1 left over, goes into 10 5 times, 65 miles an hour was the average speed that last 2 hours. Here we have a mixture problem. So on a mixture problem, we're going to set it up as the amount of solution, and we're going to multiply that by a rate, and the rate is a percentage of salt in this case. And so we end up with an amount of salt for the last part. And so we go ahead and substitute into our formula. Remember, we got part number 1, we got part number 2, and then we'll have the mix. And so we go ahead and substitute in. It says a 280 liter solution is 20% salt. Okay, so that's one of the parts. A 280 liter solution is 20% salt. So we're going to end up multiplying those. How much water should be added to make the solution 14% salt? Note, water has no salt, so no salt means 0 right there. And then we don't know how much is going to end up being added, and we want to make a solution that's 14%. So this 14% has to be the mix because it says to make. Tells us now we're dealing with the mix. So that's all the information they give us. So from here we need to figure some stuff out. So the mix is going to be the sum of these two amounts. So 280 plus x. So all you're going to do is just multiply across. And so when we do that, over here we have 2 times 28 makes 56, and then you add 2 zeros, because there's 2 zeros here. Here this just makes 0. Those get added together, and they make the final product here. So when we multiply 14 times 28, you end up with 392, and then you just have to add a 0. So let me fix that. So 392 with the 0 at the end makes 3,920 plus 14x. And so now you're just going to set those two equal to each other. 5,600 equals 3,920 plus 14x. And so when we go ahead and do the work there, we're going to subtract that 3,920 from both sides. So subtract that. And when I do that, I end up with a 0. I got to borrow a few times. All the way back from the 5, change it to a 4, 16 to 15, and do the subtraction. So we get an 8 here, 6, and a 1. And this all equals 14x. So when we do that division, we end up with x equals 120 liters. So again, you can show that by dividing 14 into that number. Well, let's take a look at our last one here. A coffee shop sells some Brazilian beans worth $5 per kilogram. Turkish beans cost $6 per kilogram. The mixture is selling for the mixture is to sell for $7 per kilogram. How much is needed to make? To make tells us the mix. To make 300 kilograms of the mixture. So let's go ahead and set up our problem. So this time we've got an amount. Instead of a solution, we have an amount of weight. And we're going to multiply it by a rate. And the rate is, instead of a percent, it's dollars per kilogram, dollars per weight. And it's going to equal a cost, which is in just dollars, because the kilograms are going to end up canceling out. And so let's go ahead and write what we've got. We've got our Brazilian and our Turkish, and then we've got the mix. So the Brazilian beans cost $5. and the Turkish cost $8. The mix is to sell for $7. And that makes sense. You got a high amount, a low amount, and the mix is in between. To make 300 kilograms means the 300 kilograms goes on the bottom, so that it's in the mix. So we need to know the amount of each. So we're going to call one of them X, the other's going to be 300 minus X, because we've got a total here. So we've got to set it up that way. And so we go ahead and multiply out, and let's see what we get here. 5X. Over here, 8 times 3 is 24, and carry in those two zeros, minus 8X. And add these numbers up, equals 7 times 3 is 21 with two zeros. So we got our problem here. 5X plus 2400 minus 8X equals 2100. And so we're just going to do some opposite operations. So we'll subtract that 2400 from both sides. Note that it's a negative 300 equals negative 3x. So I combine these two terms to get that negative 3x. When I divide by the negative 3, negative signs will cancel. X is 100. So what's X? X represents the Brazilian ones. So we've got Brazilian are going to be 100 kilograms. And then the Turkish are going to be the difference from the total. So 300 minus 100 gives us 200 kilograms. So there is our answer. Well, check out the last part for the last few problems.